Young people, welcome back. BMB in the house, taking care of some more rational expressions. You know it, guys. We got some fractions that look like crazy fractions. But let's be more specific about what we're talking about. Chapter 11, Lesson 7, Mixed Expressions and Complex Fractions. Objective number 1, simplify mixed expressions. Objective 2, simplify complex fractions. All right, guys. So concept, complex fractions, mixed expressions, skill, we got them all, guys. Basic operations, add, subtract, multiply, and divide. Simplifying, basically. I do want to say, though, mixed expressions. So kind of like a mixed salad, you know, just a little bit of this, a little bit of that. So an expression that has more than one thing going on. It's mixed with a constant, maybe a rational, maybe a radical. So a mixed expression. So when we get into it, guys, don't let the vocabulary get you. This is going to be something you can handle, especially if you were with us in the last video. We'll be getting those common denominators again. So swap back. Students will be able to simplify mixed expressions and complex fractions. Let's get it. Beautiful handout, beautiful handout, beautiful handout. And again, guys, we probably won't do all 22, but we're going to do enough to make sure that you are comfortable with this lesson. So let's get her going. First things first, guys, we just did speak on the mixed expressions. I'll speak on complex fractions in just a little bit, but a mixed expression mixed with things. I'm not going to complicate this. I got 6, which is a whole number, and then I got plus 4 divided by h. So yeah, it's mixed. It's mixed with a whole number and a rational number. So I need a common denominator to add these. 6 does not have a denominator. If it does, it's invisible, and it's called 1, the invisible 1. So let's go ahead and make 6 into something we can work with, h over h. So that's the big one in blue. H divided by h is 1. So 1 times 6 is still 6, but we're going to make it look like this, 6h over h. So now they have the same denominator, so 6h plus 4 divided by h, and that is my answer. So took care of that mixed expression. Take care of the next odd, 4b plus b divided by c. And again, guys, recognizing that I have the first term plus a rational number expression. So let's get a common denominator of c. Big C again. I'm sorry, big 1, which is c over c. Didn't even write it this time, just put it there. And of course, nothing to change for the second one because it already has the c in the denominator. Now, where did they come from? That's where they came from. I multiplied the top times c, and I multiplied the bottom by c. And of course, invisible 1 maybe? No, guess not. But 4bc now, divided by c, plus bc can now be rewritten as one single rational expression, 4bc plus b, all divided by c. And for number 5, we're doing the same thing, so this time I have a binomial in that second term, that second expression. 9, why did I say 9? D minus 5. So multiply the top times d minus 5 and multiply that invisible 1 underneath the 2 by d minus 5, and you'll get that first term, which was 2, now looks like that. 2 parentheses d minus 5 divided by d minus 5. Put everything in the numerator. So 2d, because 2 times d, and negative 10, because 2 times negative 5, plus your 4, collect your like terms, negative 10 plus 4, which gives you the negative 6, and that same denominator now of d minus 5. So for those first 3, we did the same thing in the last lesson, which was to ensure that we had an LCD, least common denominator, because all 3 of those had a denominator of 1, the invisible 1. So as I look at my next one, though, 7, b squared plus 12 divided by b plus 3. So a binomial again, b plus 3. But the first term, b squared, again has an invisible 1 as a denominator. So let's rewrite it by using the big 1 and The big one this time is going to be b plus 3. So, thank you much. B plus 3 over b plus 3. Am I going to squeeze it in there? Squeeze it in. All right. There you go, b plus 3. So b plus 3 times the top, b squared. And b plus 3 times the bottom, invisible 1. So b squared times the quantity b plus 3 all over b plus 3 plus 12 divided by b plus 3. So they have the same denominator, so now I can combine the numerators, but recognizing to multiply, distributive property, whatever you want to call it. B squared times b gives me b to the third. B squared times 3 gives me 3b squared. And then of course I got this plus 12 that I can continue to put in the numerator because they have the same denominator now. Now comes the fun part. Can you factor that any further? Well, I boxed that pretty fast. 1 times 12, 2 times 6, and 3 times 4. None of those will add up to give you the middle term that we're looking for. So we're good. All right, guys. Let's definitely get in number 9, but I think we're going to get some room. And 2a plus the expression a minus 2 divided by a. So again, you recognize one of those terms has a denominator, the other one has the invisible 1. We're going to go ahead and take care of that. Multiply top and bottom by a. And again, no need to see it, but I know it's there. 2a times a and a times 1. So 2a squared divided by a plus the a minus 2 divided by a. Same denominator, right across the top now. 2a squared plus 1a minus 2, all divided by a. And again, if you can, you could factor that trinomial, that complex trinomial on the top, because a does not equal 1. Talking about some different stuff, but it's still algebra. But recognizing now, guys, that for me is a good final answer, unless my teacher would like for me to struggle through. But let's get it. Number 10, from bottom to the top. 4r minus the expression r plus 9, all divided by 2r. So recognizing again that one expression has a denominator, the other one has an invisible 1 as a denominator. We need the same denominator, and here it comes. The first term, 4r, going to multiply the top by 2r and the bottom by 2r. Ooh, first invisible 1 I've seen all day. You go, Dale. That's me, don't worry about it. 2r times 4r, 8r squared. 2r times 1 is just 2r. But now, of course, minus the quantity r plus 9 divided by 2r. Same denominator, so we'll rewrite 8r squared minus r plus 9. Good. Minus 9, because of distributing the negative. Common mistake. I'm sure I made it already, didn't even recognize it. Maybe not in this video, but in the last one when we were adding and subtracting rational expressions. But we got it. Final answer? Yeah. Complex. Multiply give me, yeah, we're good. So, moving on up. I'm glad you said that. To the top. M minus 6, all divided by m minus 7. I'm sorry, I said that wrong. M minus the quantity 6 divided by m minus 7. So recognizing, what goes with what. So got a binomial, top times top. So now it's going to be m times m minus 7. So m squared minus 7m all over the m minus 7. Well, I didn't multiply it out yet, but you'll know the distributive property. Over here, guys, nothing changes because we don't need to. We have a common denominator now. So now it's the m squared minus 7m all divided by, oops, forgot the minus 6, all divided by m minus 7. And again, now, if I could factor that trinomial, multiplies give me a negative 6, but adds up to negative 7, I would, in hopes of getting two binomials that would cancel with one of the binomials in the bottom, or the only binomial in the bottom. But for 6, 5 minus 6 divided by f plus 2. Hear that pause? 5 minus 6 divided by r plus 2. R, f. F plus 2 is the denominator, so I'm going to use it to get a common denominator using the big 1, f plus 2 divided by f plus 2. And here we go. 5 times f and 5 times 2, 5f plus 10. Then of course we're subtracting 6 because that's the second numerator. Recognizing the speed of this one because repetition, right? So, I think we got it. Once I had the common denominator at f plus 2, it was just a matter of multiplying the 5 times the binomial, and there's nothing else to do but to add 10 and negative 6. All right. So, again, guys, as we looked at this one and we worked our way up, 2, 4, 6, 8, 10, we have a binomial in number 6, and number 8, and number 10. Recognize the binomial is in the denominator, the numerator. But knowing that I'm going to multiply the binomial times the top, the numerator, and the bottom, the denominator, does not change my rational expression. It's called the big 1. It's the same thing we did in old school fractions. So we got to do it again. But easier because it's not a binomial, it's just r, single variable. So multiply the top times r and the bottom times r, and the bottom is an invisible 1. So 8r cubed, or qr, alphabetical, divided by r, minus 2 cubed divided by r. So again, guys, since the same denominator, it's just going to be 8qr minus 2 cubed divided by r. And that's good to go. Squeezing in the last one here. Number 2, 7 plus 6 divided by p. So again, a denominator of p for one of the terms. So the first term needs a denominator of p as well. So not changing the value of it, just changing the way it looks. 7p divided by p. Now add the plus 6 for the numerator, and of course, common denominator is what we got, so all over p. Feeling good. All right, guys, so mixed expressions, again, an expression that's mixed with a rational term and a regular term, I guess. I say regular term, like even this algebra is regular, huh? Yeah, it's regular if you deal with it all day, every day, but to my students and to those watching, hey, not too regular. Ooh, complex fractions, stop, pause. It's from my editor too, y'all. He kind of likes it when I give him an indicator, so you gotta take it back. The reason why we're pausing is, can you make a fraction complex? You know, I got 6th graders going, no, they're complex enough. I got 12th graders saying, no, they're complex enough. I got 30-year-olds saying, I don't talk about fractions. Why? I'm a grown man. I'm a grown woman. We don't do fractions. But here we do fractions. And guys, complex is just saying this. You have a fraction inside of a fraction. That's why it's complex. So your numerator will be a fraction. Your denominator would be just a regular number, or value, I should say. Or the other way around, where your numerator is like 6, but your denominator is 2/3. So a fraction inside of a fraction. Or as you can see here, fraction in the top is a mixed number. Fraction in the bottom is a mixed number. And as you get to 13 over there, they're even getting rid of the numbers. They just got letters. But again, guys, complex fraction is just stating that you have a fraction inside of your fraction, either the numerator, the denominator, or both. You got it? Good. Let's get it. Service, no service. Let's go. So I rewrite it with the understanding of making it look like I need it to look like 2 and 1/2 divided by 4 3/4. So change the mixed number to an improper fraction. 2 times 2 is 4, plus 1 gives me 5, so I get 5/2 divided by, really, already? You're gonna flip it? 4 times 4 is 16, 16 plus 3 is 19. So careful, 19/4. Now, not yet. Thank you. It's still division because I have not taken the reciprocal of the second term. So there it is. Now I flip it. And of course, if you can cross simplify, go ahead. 2 goes into 2, 2 goes into 4. 5 is prime, 19 is prime, so 2 times 5, and 19 times 1, 10 19ths. So again, as I look at 12, let me read it. 3 2/3 divided by 5 2/5. Well, write that. 3 2/3 divided by, there it is, 5 2/5. Now I'm like, oh, okay, that's it? Yeah. Mixed number becomes a improper. 3 times 3 plus 2. 11 thirds. 5 times 5 then plus 2, 27 fifths. 11 thirds stays the same. I take the reciprocal of the second term and change the division to multiplication. If you can, feel free to simplify, but over here it looks like 11 times 5 and 3 times 27. And I like it. 13, what do you know? I got more letters than numbers, right? R divided by n squared, all divided by r squared divided by n. So again, nothing to do with the first term, but the second term, I'm going to take the reciprocal, flip it, and change the division to multiplication. Now top times top, Rn, bottom times bottom, r squared, n squared, or n squared, r squared. But feel free to cancel like you know you have to. If there's one r on top and 2 on bottom, they can cancel at least 1. And same thing for my n. So, really fast, but really simple, I believe. Complication can come in the understanding of flipping, taking the reciprocal of the second term and making sure that it's no longer division, it's multiplication. So keeping the routine, keeping the style. Number 14, a squared divided by b cubed. You hear that pause? Divided by a divided by b. So again, guys, just reading it can be complicated. So understanding what you're doing can help in any mistakes in reading it. So first term, a squared divided by b cubed stays the same. Change the division to multiplication and take the reciprocal of the second. And of course, 1a on top because I canceled the second a with the 1a in the second denominator, right? Same thing, I got 3 b's in the first denominator, so it cancels with 1b in the second numerator. And you get your answer. So here we go again, guys. Again, rewriting it with this division symbol, right? X squared y divided by c, all divided by x cubed, xy cubed divided by c squared. So even b and b will fumble over a couple of these guys. But following the routine, first one is not going to change, but the second one gets flipped, changing it to multiplication now. Top times top. And again, what can be canceled? Can I eliminate anything? Of course. There's c's on top and c's on bottom. Well, how many are actually left when I cancel? There's x's on top and x's on bottom, of course. How many are going to be left when I cancel? And the same thing for your y. So whether you're writing them out or you're using your exponent rules, you know to simplify your variables when they are in rational form, if they can be simplified, right? All right, so making a little bit of room now, so I got some room to work. 16, r minus 2 divided by r plus 3. All of that divided by r minus 2 divided by 3. So again, as soon as I recognize these are fractions and it's division, my mind goes keep the thing, keep the second. Keep the first term, change division to multiplication, and take the reciprocal of the second term. Now I got 3 times the binomial r minus 2, top times top, and I actually can cancel the r minus 2 at the top and the r minus 2 at the bottom, leaving me just with 3 divided by the binomial r plus 3. So again, no distributive property there, not 3r minus 6, because I can eliminate the binomial with the binomial in the denominator. Couldn't do that if I distribute it, right? All right, guys, so here we go. It's going to happen eventually. They're going to step it up on us, right? So a little bigger for you to see. There we go. And 20 has a trinomial and a binomial and another binomial. Oh, starting from the bottom. P plus 9 divided by P minus 6, all divided by, and see when I say all, now you know, okay, all of that divided by P minus 3. Otherwise, you might not have put all of it, right? So get my division symbol, and then P minus 3. So again, guys, here's that mixed expression in the beginning. That P plus, well, I can't do anything with that until, right? Order of operations, but no biggie. Show them what we got. So P minus 6, I'm not changing it, just making it look different, right? So now it's going to look like p squared minus 6p over p minus 6. And where did the plus 9 come from? They have the same denominator. Now divided by the p minus 3. And what happens, guys, is this. My brain sees that trinomial, and it goes, hold on, that's a simple trinomial. That's 3 times 3 and 3 plus 3. Or to be more accurate, negative 3 times negative 3 and negative 3 plus negative 3 gives me that trinomial. So factoring it, you can now eliminate p minus 3 in the top with p minus 3 in the bottom, right? Top times top, leaving me with just p minus 3. And then, of course, the bottom, p minus 6. Looking good, guys. So hopefully that one made sense. This is a really good indicator of your understanding. So if there was any checks for understanding, that one right there would definitely show where your areas of improvement may be needed, or where you might still have a POC, point of confusion. So for 21, I've got g plus the term 12 divided by g plus 8, all divided by g plus 6. So again, reading it and understanding, because if I wasn't talking to you guys right now, I wouldn't be saying this out loud. I'd just be writing it out. And how I say it in my head makes plenty of sense. But it's got to say it to you so that you understand. G plus 8 divided by g plus 8 is the big one, right? A green big one, showing the distributive property of g times g and g times 8. And then, of course, plus the 12 because they have the same denominator now. This is something that I showed earlier in the video in indicating why we were changing the first term so that we can combine the numerators, because when you have your least common denominator, just add the tops. Just subtract the tops, right? Don't forget to flip, so that g plus 6 was over in that invisible 1. So now it's the denominator. And of course, can I factor that trinomial, g squared plus 8g plus 12? I can. 6 times 2 is 12. 6 plus 2 is 8. So that's that shortcut that I like to talk about, guys, that you either have or you don't have. The time that you may have spent on factoring trinomials should have been valued like a $20 bill, because it's going to keep coming. It's going to keep coming. Factoring is not going anywhere, right? Difference of 2 squares, and that's why I say know the shortcuts. Yes, that's what that says, know the shortcuts. But g plus 2, g plus 6 is what the trinomial is factored down to. We still have the denominator of g plus 8, but now I can easily see that g plus 6 is the numerator over there, and g plus 6 in the denominator right here gets canceled. So now g plus 2 times 1, top times top, and of course bottom times bottom, g plus 8 times 1. And we got it, right? So that is a great one to finish up with. When I say it's a great one to finish up with, is because when you take care of 20 without me, because BMB is not always going to be there. I'll be here on YouTube for you and in some of your Teachers Clever pages. But I am here to help you out, take care of 20, guys. Remember, you can factor most trinomials, because what they're trying to do is get you to cancel binomials after doing that factoring and getting a common denominator. And like I said, guys, we had a good one today. Chapter 11, section 7. Hey, gotta love it. Can't wait to see you guys in the next video. BMB out.